tanks, so no need to carry inert gas systems for fuel tank inerting, and also provides water back into providing the aircraft with water, so again reducing the need for the aircraft to carry water. So if you look at it at an integrated aircraft level, the opportunity for fuel cells is quite exciting, and it's something we continue to push forward on. As I said, that's not the only systems item. Lots of work today going into improving power circuits, looking at more electric aircraft, optimizing the actuation of flight control systems, and particularly working and integrating systems for enhanced air traffic control and air traffic management. Power plant, lots of exciting things going on with power plant in the engine suppliers. We flew and flown recently the Pratt & Whitney geared turbofan on an A340 flight test there, just to understand the benefits of that technology, and we look forward to opportunities for that. And we're also looking at what happens with the integration of the new potential counter-rotating open rotor engines. The potential here is very large. The fuel reduction potential for those engines is very large, certainly on the bench. As I said before, the real challenges come around integration of that technology into an airframe, understanding the downsides, also understanding where the trade-off is in, if you like, the world, but in fuel emissions, CO2, so fuel usage, CO2 emissions versus noise, because certainly you can inevitably achieve a quieter engine if you shroud the fan, but you can achieve potentially a far more fuel efficient engine if you go for a bigger fan. That's the balance that we have to look at continually. We also have to look at the somewhat interesting, emotive, maybe exciting opportunity of alternative fuels. Conventional jet fuel, the kerosene, really is still a very strong contender and hard to compete with. The infrastructure's there. It's currently by far and away the best aircraft fuel available in terms of energy density, both in terms of mass and volume. And that becomes critical when we start to recognise the knock-ons into aircraft design. We've looked at the alcohols and the bioesters and the flame and such like. These really are never going to be competitive. The energy density is lower. They freeze potentially at some of the normal operating temperatures of the aircraft. Some of these materials, the creation of them competes with the food chain. So really they're not suitable and not environmentally friendly. But we do see alternatives as we look forward. If we look at the non-renewable side, the coal to liquid fuel is there, it exists, being flying today. The gas to liquid, we have actually demonstrated that. Airbus flew an A380 from Filton in the UK to Toulouse in France last year, with one engine running fully on gas to liquid, 90% I think, not quite fully. And that is an opportunity for the future. But of course those are still built upon the fossil fuels, on non-renewable fuels. So the real interesting territory is the biomass. Can we build a fuel, make a fuel, the fuel suppliers, which does not compete with the food chain, that is either built upon algae or built upon non-competing vegetable mass? And we have a research program now running, and a joint program with International Aero engines, with JetBlue, to look at that. So, suite of interesting topics, lots of technology out there, continued push for the future, and an air transport system that really continues to demand the growth. The world, us, a number of us have flown here, really need that growth of the air transport system. Society wants it, the economy wants it, and technology is critical to the bringing of solutions for the future. So, we at Airbus committed to that. It looks pretty exciting to me. The huge question is, it's got huge opportunities, huge challenges. We have to match those, and deal with them. It needs, I think, the global input to make it work effectively. We at Airbus committed to doing that, committed to setting the standards for the future. Thank you.
Thank you very much. Any questions?
Yeah.
It's the end of the day. It's a tricky question. Basically, the aim is travel. One of the most important things in travel is that you need to live together and you need to do something in a cooperative environment. On one side, we have the air and the air traffic. On the other side, as an electronics engineer, I say that's good for video conferencing. Maybe they give you it. What is your opinion?
Interesting debate, I know. Could we have held this conference by video conferencing? Maybe there's an opportunity there. I think there's been all sorts of studies, I know, about that. Can that work or not? There's even those who suggest actually that video conferencing would even lead potentially to an increase in air traffic, because what you do is to increase the availability of international collaboration, international working together, distance working together. But it's quite a long way off, a very long way off, anybody who's tried to do it, of replacing the face-to-face meeting. And in fact, the more if you're going to work a long way across the globe, right across the globe, the difficulty of working on a regular basis by meeting face-to-face is difficult. If you have video conferencing as part of the repertoire, if you like, of meeting, but you still fly and meet on other bases, then I think the two can work together in a collaborative fashion, and we've found that. If you're talking about experiencing, meeting family, going on holidays, all those sort of things, I can't imagine too many of us want to have a video conference holiday. I think it feels a bit remote somehow, and sit at home, and So I think yes, it has a role. Today, it's not so clear it will really compete. In fact, it may actually offer a further enhancement. Okay.
Thank you, sir.
Thank you very much. Last question.
Over to your left.
What is the advantage and disadvantage?
Hello. Please speak your mic.
What is the plus and minus point in coal to oil and this gas to oil, which you are saying that in comparison to jet oil?
Sure. There isn't. It's of small differences. The issue, of course, with gas to liquid is that it's still a fossil fuel. So you've still got the issue of reducing fossil fuels, and you don't have the upside that goes with the biomass or whatever, where they are actually creating, where they're absorbing carbon dioxide in the production. So you're releasing fossilized carbon that's been in the ground for millions of years, whereas the renewable energy sources are absorbing carbon from the atmosphere. So they're a cyclical process. So on a total life cycle basis, there's a benefit to renewable energy sources.
Thank you very much. So may I, on behalf of the audience, say that you should do that.